In the last lecture, what we have seen in here about 10 lectures we taken. In that, we seen the concept of delta, that is difference, and then we seen the concept of summation. Delta and summation are reverse processes of each other as like derivative and integration. So the relation between delta and summation is same as that of d and d by dx and integral. डी बाई डी एक्स एंड इंटीग्रल में जो रिलेशन है वही रिलेशन डेल्टा और समेशन में. Only for this delta we don't want the function to be continuous, but for derivative it should be continuous. For summation it is not necessary to function becomes continuous, as well as for integral. इंटीग्रल और समेशन के लिए कंटिन्यूटी जरूरी नहीं है. डी बाई डी एक्स के लिए कंटिन्यूटी जरूरी है, लेकिन डेल्टा के लिए भी कंटिन्यूटी इज नॉट necessary. That these things we want to keep in mind. Now today we will see what about generating functions and approximate summation. So first of all we will go for this generating functions. What is meant by generating function? What is meant by generating? Which generates. Generating means which generates given thing. जो भी आपको कोई फंक्शन दिया है उसको जो फंक्शन दूसरा जनरेट करता है, राइट, उससे जो फंक्शन जनरेट होता है, दैट फंक्शन इज कॉल्ड जनरेटिंग फंक्शन. सो द डेफिनेशन वी विल सी लाइक दिस. व्हाट इज द डेफिनेशन ऑफ जनरेटिंग फंक्शन? लेट ykt be a sequence of functions. Number one, if there is a function gtx which is the function of two variables t and x, such that gtx is equal to summation from k equal to 0 to infinity ykt into x to the power k for all x in an open interval about 0. Then g is called the generating function for ykt. So what is the concept of generating function? This function gts is said to be generating function for ykt if this gtx can be expressed as the power series, that is k from 0 to infinity ykt into x to the power k. These ykt becomes coefficients of power series about origin, power series in x about origin. That means what this summation indicates? Summation is like this: y0t plus, what about second, y1t into x plus y2t into x square and so on. So if gtx can be expressed as y0t plus y1tx plus y2tx square plus up to plus so on, that is power series in x about x equal to 0. Can we write this as in this way also? It is like this: a0 plus a1x plus a2x square and plus so on. How to write it? It can be written as summation 0 to something infinity an x to the power n from 0 to infinity. So this is called power series in x about x equal to 0. So ans are called coefficients in power series. So what is meant by generating function for sequence ykt? If the terms in this sequence ykt becomes the coefficients of power series in x about 0, then this whole function gtx, this whole, that whatever it may be, this whole function is called, what we call it as, generating function for y0t, y1t, y2t, that is so on, that is sequence ykt, sequence ykt. So this whole function y0t plus y1tx plus y2tx square plus up to plus so on, this function is called, or this power series is called generating function for sequence ykt. Very simple concept is of generating sequence. So the function gtx, which is in two variables, is called the generating function for sequence ykt. Ykt is a function of t only, isn't it? Y0t, y1t, y2t. So it is a function of t only. Then function of t and x is called generating function for ykt, sequence ykt, if this function can be written in this form. अगर ये फॉर्म में हम लिख सकते हैं तो ये GTX को हम क्या बोलेंगे? Generating function. Why we are calling it as generating for YKT? Because it gives like y0t into x to the power 0 plus y1t into x to the power 1 plus y2t into x to the power 2 and so on. So this GTX, this whole function generates your YKT, or YKT generates this whole function. That's why we are calling it as generating function. So G is called the generating function for YKT. YKT के लिए generating function. This is called generating function, and the second concept is exponential generating function. So GTX, if it is written as k from 0 to infinity YKTX to the power k, then GTX is called generating function of sequence YKT. Similarly, HTX is called exponential generating function for YKT if this HTX is given by summation from k equal to 0 to infinity YKT x to the power k upon k factorial. That means what? Your HTX must be written in this form. Y0t upon 0 factorial is 1, x to the power 0 is 1, plus y1t into x divided by 1 factorial plus y2t upon 2 factorial into x to the power 2 plus y3t upon 3 factorial into x to the power 3 and so on. If we write any function hx in this form, then we say that hx is the exponential generating function for sequence ykt. Exponential generating function for this sequence ykt. Exponential generating function for sequence ykt. Okay, you've got this. So this is the concept of generating function and exponential generating. We know that why we can say the exponential, because we have the exponential series e to the power x का expansion क्या है? 1 plus x square by 2 factorial plus x cube by 3 factorial and plus so on. So factorial term is in the denominator. That like it is likewise that x square upon 2 factorial, x square upon 1 factorial, x cube upon 3 factorial and so on. Such terms occurs there, therefore, and this is the expansion of exponential function e to the power x. That's why we are calling it as exponential generating function. Okay. Note that for each t, ykt is the kth coefficient in the power series for GTX with respect to x at x equal to 0. What this ykt means, what we are saying, y0t is the 0th coefficient in power series for GTX with respect to x at x equal to 0. Similarly, y1t is the first coefficient in the power series for GTX with respect to x at x equal to 0. What is y0, y1, y2 here? y0t is the 0th coefficient, y1t is the first coefficient, means x raised to 1 का coefficient है. That's why we are calling it as first coefficient. Then y2t is the second coefficient. Second coefficient means it is a coefficient of x to the power 2. Third coefficient means it is a coefficient of x to the power 3 and so on. So ykt is called kth coefficient in the power series for GTX with respect to x at x equal to 0. Now we can find the each of these y0, y1, y2 and so on. How you can find it? Suppose GTX is equal to this much, k from 0 to infinity ykt x to the power k, that is GTX. Suppose that GTX is the generating function for sequence ykt. That can be written as y0t plus y1tx plus y2tx square and so on. Now, if I put x equal to 0 in this equation, what you will get? This becomes g at t comma 0 and right hand side becomes y0t plus y1t into x. If I put x equal to 0, this term will be 0. In second term, there is y2t into x square. If I put x equal to 0 again, x square becomes 0, and so that y2t का term जो है वो भी क्या हो जाएगा, 0 हो जाएगा. X cube 0 हो जाएगा, x raised to 4, x raised to 10, x raised to 100, that is x raised to whatever power is there. Every term becomes 0, and therefore g at t comma 0 equal to y0t. That means what? You have obtained this y0t, that is the 0th coefficient of power series, by putting value of x at 0 in the generating function. अगर आपको generating function पता है तो how you can obtain y0t? Y0t is obtained by putting directly x equal to 0 in the generating function, okay. Similarly, how to find now y1t? y1t के लिए हमें ये gtx है आपके पास, gtx is equal to y0t plus y1tx plus यहाँ और भी terms है like this, y2t x square and so on. ऐसे terms है बहुत सारे, right, up to infinite तक. Now I will take partial derivative of this gtx with respect to x, that is dou by dou x of gtx equal to, क्या आ जाएगा आपका पार्शियल डेरिवेटिव? इसका अगर हमको डेरिवेटिव निकालना है, so it becomes summation from k equal to 0 to infinity ykt k into x to the power k is not there, x to the power k minus 1, summation from k equal to 0 to infinity ykt into k into x to the power k minus 1. Or what is this? First term y0t, it's a derivative with respect to x becomes 0. y1t into x, it's a derivative with respect to x becomes only y1t, plus y2t into x square, it's a derivative becomes 2 into y2t into x plus 3 into y3t into x square and so on. इस तरह से डेरिवेटिव. Now I will put in the left hand side as well as in the right hand side x equal to 0. Then this term becomes 0, this becomes 0, all other remaining terms become 0. That means partial derivative of gtx with respect to x at x equal to 0 becomes y1t. So y0t के लिए क्या आ गया आपका? g at t comma 0. Can I say that g at t comma 0 as dou by dou x of which order? 0th order. That is dou 0 by dou x0 at g at t of g at t comma 0 is y0t. Dou by dou x, first derivative of gtx at x equal to 0, it becomes y1t. आप अगर इसका और सेकंड डेरिवेटिव निकालो, dou 2x by dou 2 by dou x square of gtx becomes what? अभी वहां इसका डेरिवेटिव 0 हो जाएगा और ये आ गया आपको 2 into y2t plus 3 into 2 into y3t x, that is 3 into t means 3 factorial. इसको हम 2 factorial consider कर देंगे. This becomes 1 factorial, isn't it? So can I say that? Now see here, g at t comma 0 is equal to 0 factorial into y0t. Dou by dou x of g at t comma 0, it is 1 factorial into y1t. d2 by dx square of g at t comma 0 becomes 2 factorial into y2t and so on. In general, that means अगर आपका यहाँ हमने क्या निकाला आपका, so what we dou 0 dou x0 of g at x comma 0 becomes y0t. Dou by dou x of g at x comma 0 becomes y1t. आप सेकंड डेरिवेटिव निकालो, उसके लिए क्या आ जाएगा? dou 2 by dou x square of g at x comma 0 becomes 2 into y2t. So this I will write 0 factorial into y1t. Second I will write 1 factorial into y2t. Third I will write 2 factorial into, sorry, this is y1t. 2 factorial into y2t. So what will be your now? Then next, your dou 3 upon dou x cube of g at x comma 0 becomes 3 factorial into y3t and so on. So in general अगर आप y1t निकालते हैं y0t क्या आ गया, जीरोथ डेरिवेटिव ऑफ g at x comma 0. y1t क्या आता है, फर्स्ट डेरिवेटिव ऑफ g at xt where x at x equal to, here it is not x, it is t, at x equal to 0. This is also t, this is also t, not x. This is the value of x there. Okay, so in general now what will be ykt over now, ykt becomes 1 upon k factorial. ये k factorial इधर जाएगा, dou k by dou x to the power k of g at t comma 0. So in this way you can obtain the coefficient in the generating function. Generating functions के coefficient आपको पता रहेंगे if your generating function is known. अगर आपका generating function दिया है आपको, isn't it? And after that अगर generating function पता है, you know the y0, y1, y2 and so on. You can write gtx in the form of y0t plus y1t into x plus y2t into x square and so on. Likewise. So kth derivative becomes k factorial into ykt plus terms containing higher powers of x. That is k factorial into, so what should be there? K factorial into kth derivative. This should be not the numerator. It should be in the, it is like this. It is here k factorial. And therefore ykt is equal to 1 upon k factorial kth derivative upon dou x to the power k. Sorry, this is not, this is for gtx, is not right. This is for gtx. This implies ykt equal to 1 upon k factorial dou k upon dou x to the power k of g at t comma 0. G at t comma 0. In this way we can obtain ykt. Now if I want to find in the form of h, h में होता क्या है, only we have to take, only you have to take divided by k factorial आता है. तो ये भी आपका k factorial divided by k factorial हो जाएगा, वो cancel हो जाएगा, ये k factorial से and that k factorial because it is k factorial, और इसका डेरिवेटिव निकालेंगे तो अगेन अपॉन k factorial आएगा. if I take this as h at tx, so k factorial cancels. What you will get, only ykt becomes kth derivative of h with respect to x at x equal to 0. So either you use this formula ykt in terms of generating function, or we can use this formula ykt in terms of exponential generating functions. There are some examples. We will find what about exponential functions and what we can say that generating function. Suppose I will take first example as yk equal to 1. That is sequence ykt, इसमें हर टर्म क्या है आपका, इक्वल टू 1 है. दिस implies आपका y0t 1 है, then y1t is also equal to y0t 1, y1t it is also 1, y2t it is also 1 and so on. इस टाइप का आपको सीक्वेंस दिया है. Suppose we have given the sequence of this type yk equal to 1. We want to obtain the generating function gtx for ykt. Therefore, how you can find gtx? Gtx we know that it is equal to summation k from 0 to infinity ykt into x to the power k, which is equal to summation k from 0 to infinity. Now for any value of t and k, your yk is what? 1, which is independent of k as well as independent of t. So this becomes 1 into x to the power k. That means this is summation k from 0 to infinity x to the power k. That is, this is your 1 plus x square plus so on. ये आपका सीरीज है, और ये सीरीज है क्या? You know that this is the expansion for this 1 upon 1 minus x provided यहाँ एक mod x less than 1 provided mod x less than 1. ये सीरीज है 1 plus x square. It is a series for what? 1 upon 1 minus x के लिए सीरीज है and this should be there mod x less than 1. So this is GTX. So what I can say here now, 1 upon 1 minus x is the generating function of this sequence ykt equal to 1. 1 upon 1 minus x is the generating function for this sequence ykt equal to 1. If I take another example, this is now in before another example, I will find HTX, that is exponential generating function of same. What is exponential generating function? Summation k from 0 to infinity ykt into x to the power k upon k factorial only. So what you will get this as summation k from 0 to infinity, ykt is what? 1. So x to the power k upon k factorial. किस टाइप का आता है देखो, if I put k equal to 0, first term becomes 1. If I put k equal to 1, first term, second term becomes 1, x. Then x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial and so on. And you know that what is this? This is just e to the power x. We know this is just e to the power x. So we can say that e to the power x is the exponential generating function for ykt equal to 1. Exponential generating function for ykt equal to 1. And 1 upon 1 minus x is the generating function for ykt equal to 1. In this way we can obtain exponential generating function as well as generating function. For the second example, suppose y2i equal to minus 1 to the power I and y2i plus 1, right, is equal to 0. इसका क्या मतलब है? y2i equal to minus 1 to the power I and y2i plus 1, sorry, y2i plus 1 equal to 0. What this implies? इसका मतलब क्या है? इसका मतलब है आपका if I take now I is equal to 0, what is the first term? y0. इसका मतलब है y0 is equal to minus 1 to the power 0 equal to 1, right? y1 कैसे आता है? यहाँ I is equal to 1 रखा, it becomes y2. So you have to put I equal to 0 here. If I put I equal to 0 here, you will get y1 and it is equal to 0. y2 निकालने के लिए हमें यहाँ I is equal to कितना लेना पड़ेगा? 1. So y2 becomes minus 1 to the power 1, that is minus 1. y3 it becomes 0. y4 minus 1 to the power 2, that is plus 1. y5 becomes 0. y6 becomes minus 1. y7 0. y8 plus 1 and so on. ऐसे terms आएंगे. So in this case, what will be the generating function and exponential generating function in this case? Therefore now GTX becomes what is there? Summation k from 0 to infinity, summation k from 0 to infinity ykt into x to the power k. Can I write this as y0t plus y1t x plus y2t x square, right, plus y3t x cube and plus so on. Correct है? इस टाइप का है, right? Now what is y0? y0 is plus 1. What is y1? y1 is 0. What is y2? y2 is minus 1. y3 0. y4 plus 1. So can I write this GTX in this way equal to y0 is 1, right? Plus y1 is 0. So 0 into x 0 plus y2t is what? Minus 1. Minus 1 into x square plus y3 0 plus 1 into x to the power 4 plus 0 plus minus 1 into x to the power 5 and so on. ऐसा रहा तो इसका मतलब ये आ रहा है 1 minus x square plus x raised to 4 minus x raised to यहाँ तो x raised to 6 not 5, right? Because all odd powers become coefficients of all odd power becomes 0. Coefficients of all odd powers become 0 and plus so on. Okay, this will be plus 1. What about this? 1 minus x square plus x raised to 4 minus x raised to 6 and plus so on. What is it? Is it 1 upon 1 plus x square? 1 upon 1 plus x square, provided mod x square less than 1 and x square should not be minus 1. Mod x square less than 1 and x square should not be minus 1. Now you can say that how this obtained. What is 1 upon 1 plus x square? 1 upon, so what is 1 upon 1 minus x? 1 upon 1 minus x becomes 1 plus x plus उसका पावर प्लस एक्स क्यूब प्लस सो ऑन. तो यहाँ क्या होता है? इफ आई रिप्लेस दिस x बाय एक्स स्क्वायर और माइनस ही रखा तो क्या हो जाएगा? 1 प्लस एक्स स्क्वायर, देन इट्स अ पावर एक्स स्क्वायर टू द पावर 2 दैट इज x रेज टू 4, एक्स स्क्वायर टू द पावर 3 दैट इज x रेज टू 6. ये माइनस है तो, और अगर हम यहाँ माइनस के लिए प्लस लिखते हैं तो माइनस प्लस माइनस प्लस माइनस प्लस ऐसे टर्म आ जाएगी. और यू कैन एक्सटेंड इट लाइक दिस 1 प्लस x square to the power minus 1. a plus b to the power n कर दो. a plus b to the power n. First, a to the power n means 1 to the power minus 1, which is 1. n into means minus 1 into, इसका power decrease करो, इसका power बढ़ाओ. So it will get minus x square plus x4 and so on. So this is the GTX, that is Green's generating function for ykt. And what ykt is? Ykt is this one. y2i is ykt is given by y2i is equal to minus 1 to the power I, y2i plus 1 equal to 0. If I want to obtain h of tx here, what will be h of tx now? H of tx is only what change is there? Summation from k equal to 0 to infinity ykt upon k factorial into x to the power k, which is equal to यहाँ क्या आ जाएगा आपका y0t upon 1, y1t upon 1. Only this will be changed. y2t upon 2 factorial, y3t upon 3 factorial. So 1 as it is रहेगा. यहाँ सिर्फ divided by what you will get 2 factorial. यहाँ divided by 4 factorial. यहाँ divided by 6 factorial. So in all h of tx क्या आ जाएगा? 1 as to 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial minus x to the power 6 upon 6 factorial and plus 4. And what about this? This is just the expansion for what? Cos x. Right? It is a power series expansion for what? Cos x. 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial and plus so on. This is simply for what? This is for only cos x. ये cos x का है, isn't it? So in this way we can obtain the generating function and exponential generating functions for given functions. जो भी आपको फंक्शन दिए हैं उसके लिए आप जनरेटिंग फंक्शन भी निकाल सकते हैं as well as exponential generating function. So this is the method to find it. How to find generating function and exponential generating function. So in all what we seen here now, the definition of generating function is like this. G of tx equal to summation from k equal to 0 to infinity ykt x to the power k. And definition of exponential generating, only the change is that generating function में divided by k factorial नहीं है, exponential generating function में divided by k factorial है. That is the only change. So h of tx is said to be exponential generating function for the sequence ykt if h of tx can be expressed as this power series about 0 in terms of x, isn't it? So like this. So here also we can say that e to the power x is the exponential generating function for ykt equal to 1 upon k factorial. ykt equal to 1 upon k factorial. क्या क्या बोल सकते हैं हम? e to the power x is the generating function for which term? ykt equal to, अगर यहाँ इसमें लिखा हमने, so ये किसके लिए है? Because कोएफिशिएंट क्या है इसके? ykt equal to 1 upon k factorial. राइट ykt y0 क्या आता है 1 upon 0 factorial 1 आता है y1t 1 upon 1 factorial 1 आता है y2t क्या आता है 1 upon 2 factorial which is there. So we can also say that e to the power x is the generating function for 1 upon k factorial and it is exponential generating function for ykt equal to 1. ऐसा दोनों भी हम बोल सकते हैं. Generating function for 1 upon k factorial and exponential generating function for only 1 that we have already seen in this example. यहाँ भी हमने लिखा है तो e to the power x is the generating function for exponential generating function for ykt equal to 1. We can also say that it is the generating function for 1 upon k factorial. So this is the method to obtain generating function and exponential generating function. Okay.
Yes, sir.